There's one more thing that we have to do with polar equations, and like I said before, then we're done. We have to find area, of course. We can find the area of anything. So there are two different types of questions that I can ask you. One type is I can ask you to find the area between the origin and the curve. So let's go back to the function to the graph that we had before. We had r is equal to 1 minus sine theta. And I'm gonna try to draw it one more time. And it looks something like this. Probably nicer, but something like that. So if I would like for you to find the area inside this right here, the formula to find the area is 1/2, and we're going from A to B, and these are your theta values that get you the whole picture, like 0 to 2 pi or 0 to pi or whatever they are that you have to play with the calculator to do. And it's r squared and it's d theta. Okay, so in this particular example here, it would be 1/2, and we actually had to go from 0 to 2 pi to graph the entire picture, and I have 1 minus sine of theta squared d theta. Okay, you have this in your calculator stored as R1. So you can do a Math 9, put your bounds from 0 to 2 pi and go to vars, y vars, but don't pick function and don't pick parametric, pick polar and highlight R1, and it will insert 1 minus sine in there for you, squared d theta. When you get your answer, make sure you take half of it. I have 4.7124 if I did that correctly. So that's one type of area question that I can ask you. There's one other type of area question that I can ask you, and that's where I give you two graphs. Okay, so I would like you to clear out your y equals, and I would like for you to graph r is equal to 1, r is equal to 1 minus cosine of theta. And once again, I'm gonna try to draw the pictures. I'm running out of markers that work here. R is equal to 1 is actually a circle. It's a unit circle. Radius is 1. 1 minus cosine of theta looks something like this. Let me get, I have no colors. That color you can't even see. And it looks like this right here, okay? So when I give you this right here, there are different ways that I can ask you to figure out. There are different regions all over here. So the first way that I want to ask you is I want it to be outside the circle, outside of r is equal to 1, and inside r is equal to 1 minus cosine of theta. And that's this piece right here. It looks like a crescent. That's this piece right here. So what we have to do is we have to find out where they intersect. You can see from my graph pi over 2, 3 pi over 2. We can also have negative angles. So I'm going to stick with the positives. Pi over 2, 3 pi over 2 are two options. Negative pi over 2, negative 3 pi over 2 are two more options. And for no reason other than the fact that I want to stay with positive angles, go in your calculator and change your window. Let your theta min be pi over 2. Let your theta max be 3 pi over 2 and hit graph. And when you do that, you'll actually see that you get the piece that we want. Okay, so that's a big deal. We were able to adjust our window. Just like before, when we had two radii, remember it was a capital R squared minus a lowercase r squared. We do the same thing. We have 1/2, and we're going from A to B. These are our theta values, and it's the larger squared minus the smaller squared d theta. When we're trying to figure out what's your capital R and what's your lowercase r, if you're starting at the pole and I draw a line to this graph and to this graph. Okay, first I'm going to go to here, then I'm going to go to here. you can see that the 1 minus cosine theta is my larger one. Okay, so when I'm setting this right here, I'm going 1/2, and I'm going from pi over 2 to 3 pi over 2. My larger one is this right here. It's 1 minus cosine of theta squared minus my smaller one goes to the circle. 1 squared d theta. And that will get you the area that's outside the circle and inside this red piece right here. Okay, I can ask you another question. Same two functions. I'm gonna just try to redraw this picture and clean it up a little bit. I'm running out of board space. I'm running out of markers that work. This is awful. Okay. So we have r is equal to 1 was our unit circle. Something like that. And then the other function looked like this. Right here. And now using these two, let me just state a different function. I want you to find the area of the region shared by both. Okay, so the region that's shared by both is actually this right here. If I were to color them each in, this right here is shared by both. The points of intersection were all up here. I'm going to ask you to let your theta min be negative pi over 2 and let your theta max be positive pi over 2. I'd like you to try that and see what region you get. Even though we might not get the right region, it can still get us the right answer. So when you change your theta min and your theta max, you get this region right here. If you can see it, I'm trying to go over it in blue. Okay, it's the wrong region, but it can get us, and it will get us the right answer. You know how to find the area of a circle. Area of a circle is pi r squared. My radius is 1. So if you find the area of the circle and you take this piece away, you're going to have the region that's shared by both. So the region that's shared by both would be the area of the green circle, which is pi, and my radius squared is just 1 minus 1/2. My bounds are negative pi over 2, positive pi over 2. Remember, it graphed that piece right there. So when I'm drawing in my r's, this is one of them right here, and this is one of them, very small one right here. My larger one goes to here. So I have 1 squared minus parentheses 1 minus cosine of theta squared d theta. And that will get you the region that's shared by both. Even though this gets us the wrong region, we can simply subtract it from the area of the circle, as we know. One more thing, you're done. You've covered absolutely everything that you need to know in BC Calc. You finished Calc 1, you finished Calc 2. Congratulations, and thank you for sticking with me.